they can get the recording. Okay, cool. So go for it. Tell me about the plague.
I don't know the details, but it was pretty bad. And then, like, his family brought Isaac home, and then he discovered, like, gravity and stuff.
That's fantastic. That's a great start. That's a great start. Who knows something else about what Isaac Newton purportedly did during the bubonic plague of 1667? Ben B?
Oh, I just had it up.
Okay, how about you, Jack? Walker? Oh yeah, go ahead, Jack.
So kind of like what the first two people said, like so he came, his school got canceled like ours for the plague, and then they had to go home, and then he like thought of these things. And last week you said that you were like, just think of what we could do if he could do it.
Yeah, that's right. So has anybody been thinking about what they might do? Because I have to tell you that something that comes to mind for me is I'm really interested in optics. Okay, so not only did Isaac Newton, and he didn't really, David, he didn't discover gravity as much as discover the laws of gravity, right? So gravity was already there, right? It was just that nobody really understood the relationship between how the planets orbited and how gravity worked therein. And so he also worked on optics with telescopes, all right, which was really cool. And so I wanted to give you a picture of something that is really attributed to Isaac Newton. And so what I'm going to do is I'm going to share screen, and then I'm going to have to move all my windows over. So this just takes about a minute or two. Let's see, I move that over there, and I hit participants, and that allows me to see everybody at the same time. And then I also can hit chat, and that allows me to see all your chats at the same time. And then I go to this screen, which is great, and I get to expand it and see all of your faces. So that is awesome. Now we're gonna go to, and where is it here? Okay, so this is gonna be a discussion of optics, okay? So, and why is it not expanding all the way? Maybe I can do that with this. Okay, that works. So can you tell me what is kind of strange about her eyes? Who's gonna kind of, Bridget, what do you say?
Oh, isn't one eye when it's dark outside and one eye when it's super sunny outside?
Ooh, I love that. That's a great start. How about you, Lila, and then Walker?
One of the pupils is expanding because there's not as much light, and one of them.
Which one? Which one is expanding?
The one on the left.
So the one where her pupil, the dark part, is bigger. Beautiful, beautiful. Walker, what were you going to say, buddy?
One of them is very dilated.
Dilated. Can you explain to me which one is dilated?
The one on the left.
Yeah. Does anybody disagree with that? Because do you know that if you ask 100 people, and Michael, I can't see your video. That's okay if that's your choice, but I'm just going to ask to start if you want to join us in that way.
Yeah.
Yeah. So let me, if you asked 100 people, you said, what does dilate mean? They would say to make larger. Okay. Now I'm going to help you understand why that is not true at all. When you go to the eye doctor, however, they do dilate your eyes to make them bigger. And can anybody tell me what is the scale factor of this dilation? So what do you think? And raise your hand electronically if you can see the diameter of the smaller pupil, the diameter of the larger pupil, and kind of in your estimation, what do you think the scale factor is? We would have to multiply the smaller by some number to get the larger diameter. So I'm gonna have you guys just chat to me your answers. And Ben B, I want you at some point to teach me how to create that face that you did, where you're using like Arabic or something. Is that Arabic?
I just like found it on the internet and I copied it and then I pasted it.
Okay, I'm gonna show you guys what I am looking at right now because you can't see it.
He did it before.
Really
Yeah.
cool.
Everyone.
We can see it.
Yeah.
Yeah,
Yeah.
we can see it.
Oh, you got that?
He put it in the chat earlier on.
Oh, you did. Because I'm thinking that these might be Arabic numerals, maybe. I just don't know. But anyway, it's very interesting to me, Ben, and I'm gonna actually look into it. So, all right. So the chat you sent me, I got 8 chats. Ooh, Olivia, interesting. Hannah, I totally agree. So Olivia and Hannah. Hannah, talk to me about your number and then I'm going to talk to Olivia about hers. Go for it.
Well, I got 3 because first I thought it might be half, but then I thought that it would be too small for that, and then I thought maybe that the smaller one could be a third of the bigger one, so times 3.
Yeah, I like it. And what I'm going to do, Hannah, is I'm just going to literally put it right up there. Do you guys see now that it's about a third? Pretty cool. All right. So yes, this has a scale factor of 3. Can anybody give that to me in percentages right now? Just throw it out there if you know it.
33.
So this is an expansion of a multiplier of 3. So what percentage, when something grows to 3 times its size, it has grown by what percent? Walker?
300%.
And that, my friend, is 300%. Now, Olivia, I got some big pupil. I want to dilate that pupil so I can look like the smaller pupil. What is the dilation factor from big to small?
Is it a third?
And what do you guys think about that? If Hannah is right about a scale factor of 3 from small to big, then Olivia must be right from big to small. And who can tell me the percentage?
0.3 repeating.
3?
So point what?
3 repeating.
I don't agree with that. As a percent?
No, we said 33.3.
Ah, so it's 0.3 repeating as a number, but it's 33.3 repeating percent. Okay? So
Didn't show up.
if anybody ever, and Thomas, why don't you unmute yourself? If anybody ever says to you, hey, dilation means getting bigger, what are you going to say to them?
No.
Based on what you know now, what are you going to tell them about scale factors?
It
If
can
your
also
scale factor, what happens if you have a scale factor of 1? Then what happens?
stays the same.
Yeah, it's no change. And do you know the Greek symbol for no change? Anybody? mathematically oriented Greek symbol. It's the fourth Greek letter. So anyway.
4 lines.
Delta?
mm, Oh, who said that?
Ellie?
Ellie. Delta is actually used, they use a triangle for delta. And since delta means change, I would put a delta and then a line through it. Okay, which is kind of a cool logo. So a scale factor of 1 is what percent, by the way?
100.
100%. And 100% of me is me. 100% of you is you. Now, what about a scale factor that is greater than 1? What can you tell me about that? And I can call on you guys, or you can raise your hand. I'd love to hear what you have to say. Come on, who's got some ideas here? And if you're wrong, oh my God, you're wrong, and that's okay. Remember how often Isaac Newton was wrong until he was right. All right, come on, scale factors greater than 1, like 3. What happens to the image?
It's bigger.
Yeah, it gets bigger. Now, what happens to a scale factor that is less than 1? Like a third.
It's smaller.
And what is wrong with my formula? This formula is a good formula, but it's still wrong. What is wrong with it? There's something wrong with it. There's something missing from it that would make it correct.
Oh, you never said anything about 0.
Ah, so what about 0?
If it's 0, then there's no image.
Who said that?
Me?
And
Ben.
me would
Ben
be
B.
helpful if you said your name.
Ben B.
Ben B. Guys, if it has a scale factor of 0, it disappears. It literally goes from 100% to 0. It has to be greater than 0 and less than 1 to go smaller. And so when somebody says to you, well, dilate means getting bigger, you say, no, it doesn't. Dilate means change. So if you apply a dilation factor of 0.5, you're getting smaller. A dilation factor of 2, you're getting bigger. So now let's go to some of my favorite optics. Oh, and by the way, do you know why the doctor, the eye doctor, dilates your pupils? Do you know what her purpose is when she does that?
Did you make them bigger or smaller?
Yeah, when they put drops in, it actually makes your pupils bigger. Thomas?
To see into your eye better.
Ah, do you know what happens, Thomas, when they put a light in your eye? What happens to your pupils?
They get bigger.
No.
Oh no, they get
get
smaller.
smaller because your eyes are protecting you. Do you understand that you have some
that's
pretty
what-
important machinery behind your eyes? Your retina, your brain, the blood vessels, like all that stuff that's behind your eyes. If your pupils are open and big light comes in, is that going to be bad for you?
Yeah.
Yeah. So guess what he does? The doctor dilates your pupils artificially with droppers. He then or she then puts a light into the eye and magnifies it and can see inside all the way to the retina. And I think it's pretty cool that they do that. So I'm kind of a big fan of optics, and Isaac Newton had a really big part in those optics. So now let's talk about chess pieces. We have a scale factor of 1 for the original knight. Who can give me, and Hannah and Olivia were right on, who can give me the scale factor of the small and the big? Can you please chat that to me right away? And you can do in the order of small to big. And I gave you also the width and the height with these red lines. So hopefully that's going to be a little more helpful. Very nice. Very nice. Huh. Now, Ben B, you said a quarter and 4. Let's look at that for a second. And Ben, you see the height of this guy?
Yeah.
What's the factor? How many times?
What?
How much?
Twice.
It's twice. So most of you said correctly that we've got a scale factor of 1/2 and a scale factor of 2. Now, what about the area? If I say to you, the surface area of the original is, I don't know, let's call it A. What would be the, and that's area. What would be the surface area of the small? Why don't you raise your hand if you have an idea? And actually the chat would be really cool. If you could send me a chat with what would be the area of the small. I'd really like to know what you think. And we're talking, you know, surface area, guys. Take your hands and make believe you're touching the surface of the knight, of the chess piece. How much surface would you be
How much
looking
does
at?
the original have?
Say again?
How much does the original have? Surface
The
area.
original, and I know that this is not a very satisfying answer, but the original has A. So, Bridget, I'm not going to tell you the number, because I don't know the number. But I know that if the original has A area, then what does the small have? All right. Hi, Cedric. All right. Go for it, guys. On 3. 1, 2, 3.
4
Divided by 4.
There it is. So guess what it is? It's A over 4. It's A over 4. Now, using the same idea, and Cedric, what we're doing right now, Cedric, is we're looking at the surface area of this original scale factor of 1 versus a scale factor of 1/2 and a scale factor of 2. Surface area, everybody on 3. 1, 2, 3.
4A.
4A.
And it would literally be 4A. Now, let's move to volume. The volume of the original was made of V cubic units. What do you think would be the volume of the small? And I want you to send me a chat on that. The volume of the small in cubic units, the volume of the big. The volume of the small and the volume of the big in terms of V. I don't know what the volume is, but it's some value. All right, let's see what you got here. Now, I'm talking, Olivia, about the volume of the small and the volume of the big. So the volume is definitely going to be smaller for the.
What?
I know, but like,
Yeah,
I
go
was
ahead.
talking.
Doing the same.
Olivia, did you have something you wanted to ask?
No, but
And we can't see you. I can see your cat, but if you could move your screen, you don't have to move yourself. Just move your screen. Okay. What do you guys think about the small? What's the volume of the small, guys? Go. Say it out loud. And by the way, we've got a lot of muted people here. And
V units cubed over 4.
huh, interesting. I don't think I
V
agree
over
with
4?
that. Say again?
V over 4?
No, that would be the area. That's in 2 dimensions. Volume is in 3 dimensions.
V over 4 cubed.
Can we try V over 2 cubed? What is that, guys? Come on, what's 2 cubed? 2 times 2 times 2.
8.
It is 8. So the volume of the small is literally going to be an eighth of a volume of the original. Now, what about the volume of the big? How many times bigger than the volume of the original is that going to be? Don't say it out loud. Send me a really quick chat. Ellie nailed it. I want everybody chatting to me. Ellie, you nailed that. Bridget, you nailed it. Ben, Olivia. Bigger, Jack, bigger. Hannah. Ben, a little bit too big. Oh, but wait a minute. Ben, something very interesting. Most of you said 8B. Most of you said 8. And wouldn't it be 8 because isn't it 2 cubed? Right? Now, Ben said something interesting. Ben L. You said 64. Can you tell me how 64 might be a relevant number here in this process?
Because in that small one over there, it was 2 cubed because it was like 2 times like the length and width smaller. But this is like, it would be 8, so you would do 8 cubed I thought.
So guys, you want to see something cool? You ready for this? Let the volume of the small be Q. You ready for this? What's the volume of the big if the volume of the small is Q?
64 Q.
Do you guys see it? So this is literally 64 times bigger from volume perspective, even though it's only a 1-to-4 ratio. Because a 1-to-4 ratio, guys, come on, or a 4-to-1 ratio,
4
if you
cubed.
cube those numbers, what's the cube of 4? Come on, 4 times 4 times
64.
4. And 1 times 1 times 1?
1.
1.
And therefore a factor of 64. So I hope you guys really like the mathematics that we just showed there. Now, let's go to a coordinate system. Why don't you guys go to page 3 in your packet, please? Go to page 3. And I want you to look at the 3 triangles. Now, if you look at these 3 triangles, do you see a relationship between the scale factors? If I tell you that the scale factor of B has a scale factor of 1, the scale factor of C has a scale factor of, anyone?
2.
2, and the scale factor of A?
1/2.
1/2. Can you tell me why is this point 2, 3, and this point is 4, 6, and that point is 8, 12? And why is it 5, 1, 10, 2, and 24? Who can give me kind of a mathematical explanation for what happens to these coordinate points? And I'm going to go with, let's go with David on this one, and I'm going to go to Ben B. Go ahead.
Because
And
on the top point of the triangle, the first coordinate is doubling, so 2, 4, 8. The 2 doubles and then the 4 doubles.
So guys, do you guys see it? 2 to 4, 4 to 8. And awesome. And what else do you see, Ben B?
I was just gonna say the same thing as him.
Okay, great. How about Jack? Did you have something else, buddy?
I agree with them. And also, it's for the second numbers because 3 goes to 6, 6 goes to 12. And then it's the same for the bottom one. 5 goes to 10, 10 goes to 20, and then 1 goes to 2, and then 2 goes to 4.
So let me ask you guys a question. If we, and by the way, whoever is in a house with piano being played, can you just mute yourself? And that way we know that we don't all have to listen to that. And I'm gonna just request unmute here and David as well. Now, if I have a theoretical triangle D, can you please, and by the way, D has a scale factor of, what do you want to give it?
4.
We can give it 4, but why don't we give it 5, just for fun? What is the corresponding point to this upper vertex of the triangle? Send me a chat on that. Send me a chat as to what you think the corresponding point would be in the uppermost point. So I'm looking for a chat that would give me the coordinate in a scale factor of 5. And remember which triangle has a scale factor of 1 in my example. And I'm looking for a chat. Ooh, nice, nice. I don't agree. 20, 30. Ben, I don't agree. I don't agree with anyone yet. Jack's got it. Olivia's got it. Olivia, remove that question mark. I want you to be confident. And Lila, you want to give me a thought there? I've got Jack and Olivia only. What do we do with this 5? James, what do you think? What do you want to multiply 5 by? Well, where is the point where there's a scale factor of 1? What is that point?
It's
Isn't that the point 4, 6?
4, 6.
Yeah. So what do we have to do with the scale factor of 5, everybody? Come on, what are we going to do to it?
Multiply it by 5?
Multiply it by that.
Yeah. So 4 times 5
Oh.
and 6 times 5. So we get the value 20, 30. And that is the coordinate that would give us a scale factor of 5 in relationship to B. Is everybody 100% on that? If you're not, raise your hand electronically. I want to make sure you got it. All right? Now, I've got another challenge question for you. So, and this challenge question is, and I don't think I like that picture right now. The other challenge question is this. If I told you that I had another triangle, and this was triangle E. Now this is going to be harder, guys. I have triangle E with a scale factor of 2/3. By the way, there's a lot of noise on someone's background. There's a phone going off or an alarm and some parents. So just mute yourself. That's no problem. Thank you. If I have a scale factor of 2/3, what would be the corresponding point for 4, 6? So I'm looking for the corresponding point of 4, 6 for a triangle with a scale factor of 2/3. So please send me a chat on that. And you're going to need to know how to multiply fractions. So if you want to take 4 and multiply it by 2/3, you're going to have to know how to multiply fractions. Who wants to explain the process of multiplying fractions? Go ahead, Jack.
Huh?
Jack, you raised your hand. Go ahead and explain it.
I did.
Okay, go ahead. Go ahead. Walker is fine. You can do it.
You do numerator, you multiply the numerator by the other numerator, and you multiply the denominator by the other denominator.
And what do you get?
8 and 3. So 8.
Well, you want me to say 8 and 3?
8/3.
8/3. Very good. Guys, you just got the x coordinate of that point is 8/3. Now, who can give me the y coordinate of that point? Because now you're going to be taking the 6 and you're going to be multiplying that by 2/3. But this is a little easier. Who wants to take this? Who wants to take this one? And raise your hand electronically because it comes up right on my screen. And then, all right, Jack D, go for it.
4.
I don't exactly agree. Why don't we go with, let's see, James.
I mean 3.
Say 4, 2. Because I multiplied 2. Yeah, I was going to say 4, 2.
Yeah, guess what? I agree with that. I like the 4. You were right the first time. So it is 4. But what I like to do here, guys, is I like to cross out the 6 and the 3 because 6 divided by 3 is 2.
It's 2. You got to cross cancel.
And then I can just do 2 times 2 and my life is really easy. Now, 12 divided by 3 is not so bad, right? You can still do that. But the point that we just found is 8/3 4. Now, who can help me find 8/3 4? Come on, where is it on this scale? Now, 8/3 is what? Come on, you can help me out.
2 2/3.
Is 2 2/3. It's right here on the 2 2/3 elevator. And now I want to go up to where?
4.
And guess what, guys? That's my point right there. Now, what about this point right here? 4, 2. What would that corresponding one be? Come on, work it out on your paper. 4, 2. I want to convert 4, 2 to a factor of 2/3. 4, 2. Come on, you guys work it out. And don't say it out loud. Just send me a chat. So we have 4 and we have 2. All right, let's say it, guys. On 3. 1, 2, 3.
8/3.
8/3. Comma
5,
what?
6. 5, 6.
I don't think so.
4/3.
4/3. So 8/3, 4/3. So everybody help me find it. 8/3 is in the same place, and 4/3 is about 1 and a what?
1 1/3.
1 and a third. Now my last point is 10/2. Can you guys all please do 10/2? So quickly, 10 times 2/3, and then 2 times 2/3. And all you really need to do is 10, and what do you guys get, guys? Go ahead.
20/3.
20/3.
20/3.
20/3
Yes, 20/3.
over,
4/3.
4/3.
and 20/3 is really close to what number? Or what is that number?
7.
Not 7, really close
6
to it.
2/3.
Yeah.
6 2/3, and then up 1 1/3. And now, guys, I will literally give you a dilation of 2/3. A dilation of 2/3 would give you our brand new triangle. And I just want to show you one thing that I love. When I do this, guys, look what happens when I start at the origin. I go from the origin, and I can hit every one of these vertices, and they will all be in a straight what?
Line.
Line.
Isn't that cool? And this is what, if you ever took an art class and you learned about the power of perspective, like looking down train tracks, and how the train tracks appear to be getting smaller and smaller, this is called dilation. All right, I want everybody now to go to page 6 in their packet. And this should take you just a few minutes. Not everybody's going to finish. Go to page 6. And what I want you guys to do is I want you to dilate this night to a factor of both a scale factor of 2 first, and then a scale factor of 1/2. And the best thing to do is start with a point. Any point you want. Multiply it, the x value and the y value, by 2. And if you have a question, please ask it. Jack, do you have a question? Or is that all? That's from before. And if anybody wants a little push, like Kramer, I need some help getting started, I'm happy to do that. So Walker, you working this? Come on, pick up that pencil. And Ben B and Michael, I can't see you, so I'm hoping that you're picking up your pencil and working page 6.
Wait, I don't have a packet because my parents said they didn't see one.
Oh, so it was in the invitation, Cedric.
Oh.
So Cedric, what you're gonna have to do, you have it better. Cedric, why don't you write down each vertex of the night and just write down the coordinates of the scale factor of 2 and the scale factor of 1/2, and then when you get your packet printed, then you can actually very easily do it because you've already done the work.
Okay.
That makes sense?
Yeah.
Okay, excellent. So guys, I'm starting with 2 2 because 1 1 converts to 2 2. 2 4 converts to 4 8.
Oh, you're dilating. Oh.
Is anybody bothered by the fact that there's no 12 on the y-axis? -3, 5. And I'd love to get any questions. Somebody has pots and pans going on in the background. If you can mute yourself, that'd be great. Thank you. And if you're finished with the dilation of 2, do the dilation of 1/2, please.
1.1 and did that one for them too.
And if anyone has a question, please ask it. This is a great time.
Why does the packet not go up to 12?
When you say the packet doesn't go up, oh, you
Why
mean
does it only?
you know what? Because I wanted to see what people would do. I wanted to see if they would just go, oh, there's no 12, I can't do it. Or if you just literally estimate 2 points up. So Francesca, that's a great question. -2, -3 is -4, -6. Ellie, are you done? Ellie, are you finished?
I think so.
Well, then you should, have you done already the scale factor of a half?
No.
Okay, then you should be doing that now.
Okay.
Questions, anybody? And there's my scale factor of 2. Now I'm going to go for a scale factor of a half. Somebody's got a beeping going on there. If you could mute yourself or stop the beeping, either way. If anybody has a question, please raise your hand electronically. Somebody has a beeping that's going on. I'm sure you can hear it. If you could mute yourself, that'd be great. Just that one person.
Well, I think the person, it would be coming from it's coming from all of our computers, so we wouldn't know who it is.
No, it's only one person. So,
yeah, I know, but then we're all listening to each other.
Right. Anyway, Olivia, if it's not you, don't worry about it. I'm only concerned about the person who it is.
Mm. Let me see.
And it stopped. Thank you.
Let me see someone.
So which one's harder? The 2 or the half?
Half.
Half.
Definitely.
Half. Half.
Yeah, I find that really challenging.
My friend's spamming in all of his chats. I don't know how to stop. I'm gonna mute this side.
Oh, thank you.
It should stop.
Thank you, Olivia. How are we all doing?
Good.
Anybody finished with both? I'd love to see your pictures. Can you hold them up to the screen really nicely, up to the camera? Wow. Nice job. Beautiful. Love to see your progress. Hannah, Cedric, Lila, Walker, Olivia, not Olivia, James, Bridget looking really good. Looking really good. All right. I want to make a move right now, guys. I want to make a move to, and I think, no, that one is just pretty, but not difficult. Let's look at A. So can you guys go to page 13, please, and everybody unmute themselves?
We're not done.
Well, no, you're going to go to, you're going to finish it during the week, but I want to make sure that this one is doable. All right, so everybody go to page 13, please. And I want you guys.
There's the letter A on it.
Can
Yes.
somebody please choose a point on the A? So somebody choose a point that is not too simple, and maybe that has a negative value. So can somebody choose a point that has a negative value? I'm going to request unmuting from you guys so I can hear you.
Maybe negative
Who's going to
2.
come up with a value for me? David, go for it.
-2. Sorry, 2, -1.
So 2, -1. Okay, I like that. 2, -1 is right there and a really good point. Let's work with it. Let's work with it. Everybody write down 2, -1. And find for me the corresponding point with a scale factor of 5/2. So we're going to be doing 2 times 5/2, and we're going to be doing -1 times 5/2. And I want you guys to write down the point that you think it is. And remember, you're cross-canceling your 2's. And what do you guys come up with? On 3. 1, 2, 3.
5
and
this.
5 and what?
And -2.5.
Yeah, well, guys, just -5 over 2. So 5, -5/2. So 5, -5/2. Everybody plot that point. So everybody go to here, go to 5, and then negative what?
5/2.
Which is about which is exactly -2.5. So you just found the corresponding point for point 2, -1 that David gave us. Now go to every single point and do the same thing. So I'm going to leave this up here. I'm going to go to this point first, 0, 4. So that's going to have to be 0 and then 4 times 5/2. And then I'm going to connect. And if anybody has any questions, this would be a really good time. Now somebody's making a noise, like an electronic bouncing noise. It could be somebody texting you or something. If you can let them know not to do that, that'd be really helpful. So -3, -7.5. And if you have any questions, this is a great time to ask it. You know, some people haven't done a lot with subtracting fraction or with multiplying fractions. This is a great time to ask the question. Raise your hand electronically. So even if I don't see your video, I'll know that you have a question and you can ask it. Or you could ask it on the chat. Go for it, Francesca. Give me a point.
Well, this isn't really about like multiplying fractions, but do all of like these like have ones that like go off the chart?
Oh, that's a good question. I don't think any of them go off the page. I don't think any of them do, but that's a great question, Francesca. Lila, which point are you trying to multiply by 5 halves?
I'm doing 0, 4.
Okay, so Lila, 0 times anything is going to be what for sure?
0.
And 4 as a fraction times 5 halves. Can you cross cancel, Lila, the 4 and the 2?
Yeah.
And so what do you put up above the 4?
A
4 divided by 2 is?
2.
And then 2 times 5 is?
10.
And there it is. So your point is 0, 10. Does that make sense? And it's right there.
Yeah.
Cool?
Mm-hmm.
Okay, excellent questions. Excellent questions. So keep them coming. Keep the questions coming. Francesca, go for it.
This is another question. Like, what if you know that two lines are the same distance? Then do you just draw them like the same?
Yes.
Like,
Yes. For instance, when I did this horizontal line up here, Francesca, do
yeah.
you see how this one definitely is only 1 long?
Mm-hmm.
So I multiplied 1 by 2.5, and that's how I did that point. Does that sound like a good strategy?
Yeah.
But this one's a little harder. James?
Yeah, so I'm trying to figure out to do -1 and 1.
So -1, 1, let me see it. -1, 1, right here, yes.
So how would I multiply that?
So James, watch this. -1 is really -1 over 1. Do you agree?
1, yeah.
And if you multiply that by 5 halves, the 5 halves doesn't change, but when you do a negative times a positive, what do you get?
Another negative. Oh, so it'd be negative again.
So
Okay.
your corresponding point there, James, is
Yeah.
-2.5, positive 2.5.
Okay.
Right there.
Okay.
And that was a great question. If you guys just keep asking great questions, then this is going to be one of the best groups there is. I love it.
Mr. Kramer,
Yes.
I'm trying to figure out the point where it's -1 and 1/2 and -1.
Wait. So say the point on the blue A first. Say the point again on the blue A.
-1 and 1/2 and 1.
So -1 and 1/2 and 1. Where do you see?
My thing isn't done yet.
Where do you see that? And who's asking the question? Because I didn't see the hand go up.
Bridget.
Oh,
Oh,
Bridget. Go for it.
it's like the middle left-hand
You have to,
bottom corner.
but Bridget, there is no negative 1.5, 1. Negative 1.5, 1 is here.
Oh shoot. No, no, not -1.5, 1. -1.5, -1.
Oh, this point right here.
Yeah.
Okay, so that is -3/2
Oh shoot.
times 5/2 is -15 quarters. -15 quarters. Does that make sense?
Yes.
Okay, and where is -15 quarters?
Uh,
I mean, that's a little bit, that's a quarter less than -4, isn't it? Or a
Yeah.
quarter more than -4. So you go to -4 and then a little bit less, and it's right about there. Does that make sense?
yeah.
Okay, great. And -2.5, -2 is right there. So guys, we're gonna make a little stopping point here. Everybody put their pencils down and just look at my screen. I gave you some really fun ones to think about. This is probably the hardest one there is because you have to multiply everything by 5/4 and 2/3. And this one here is practically a circle. Now, it's not a circle, is it? Is that a circle?
No.
No. It's actually a 24-gon, and you're going to be dilating this to a factor of 2/3 and 1/3. And then the most fun is I've given you create your own. So you create your own letter or picture or anything, and you can dilate it to any factor you want. I gave you 3 of these. I gave you 3 of these. So I am going to now choose a number. I'm going to choose -260, and I want us all to count by 26 up to 0. Actually, no. Let's count by 130 because we're out of time. Everybody go. -260.
-130.
But don't ever say -0. 2, 4, 6. We appreciate mathletes. Go mathlete. I will see you guys in 167 hours or so. You guys have a great afternoon and have a great evening. I'm trying to shut off the share so you can say goodbye to your friends in a larger scale, but I can't follow. There it is. All right, guys, you have a great one. Enjoy. And Cedric, if you can't find the file, have your mom send me an email on that.
Okay.
All right. Take care, guys. Bye.